Hello YouTube viewers, welcome to my channel. I am Sri Tips, and today I'll be working on part 6 of the stock pot refining video series. My goal today is to get that gold cleaned up, purified, and then we're going to work on getting the platinum group metals out of the solution, cleaned up, get all the zinc cleaned up out of it, and get the black powders, the mixed platinum group metal powders, cleaned up and ready for refining. So, without any further tomfoolery, no more ballyhoo, let's get right to it. Part 6 of the stock pot refining video series. Everything's been allowed to sit and settle for the last 2 days. I had to take a break from here. This has got a little bit of a amber tint to it, so I'm going to add some more zinc to this and a little bit of hydrochloric acid to get all the rest of the PGMs to come down. Here's our gold solution. What I'm going to do, this is actually the precipitated gold from part 5. We'll set this up out of the way. I will get this refined and get it cleaned up so it's absolutely pure gold. In the comment section, a lot of folks will make a reference to ice cubes being impure or to adding sulfuric acid and causing a problem. Neither of those two things caused this problem. I've had this happen before. There's probably some rhodium or something else that came over out of the stock pot and was contaminating the gold. I've had it happen before with my jeweler's waste. The jeweler's waste had some rouge in it, and it kept following the gold through all the precipitations. So I just got to do a few more precipitations on this, and we'll get this cleaned up. To get the rest of the metals to cement out, it's been sitting for 2 days. Some of the metals have gone back in solution. So what I'm going to do here is add just a splash of hydrochloric acid here, not much. Stir it up. I don't feel anything. Yeah, there's some stuff in there. There might be some zinc already in there. There's a piece. So I should just be able to maybe add a few crumbs of zinc here. I've got some cut up strips of zinc. I'll add a few of them to the solution here. And we'll just let this set for a little while. Precipitate out the rest of the platinum group metals. One thing that does concern me is that foam. While I'm waiting for this to react, I'm going to set it up here back out of the way. I'll bring the gold down here, and what we're going to do is we're going to run this through another refining cycle, see if we can get this to clean up. Rinse the gold with a little bit of hydrochloric as before. Okay, now we're going to put the gold into our beaker here. And we're going to add some hydrochloric acid. About 50 ml. Now I'm going to put in a few drops of sulfuric acid. I do this as a matter of habit. It hurts nothing. It provides a benefit in that if there's any lead whatsoever in here, it'll come out. Lead. Now I'll add some concentrated nitric acid here. That's 1.5 ml. Another 1.5, so it's a total of 3 ml of concentrated nitric acid. Take this, put it up on the heat now. These next 2 clips are speeded up 16 times. I've got 3 ml of concentrated nitric in there with the gold, and I was sure that that would be enough to get this gold to go into solution. Here I think coming up you'll see me add another 0.5 ml. There it is. So I got 3.5 in there so far. These reactions, they never go as planned, it seems. Here's another 0.5 ml, so now I got 4 ml in there. Another half, so I got 4.5. And that's another 0.5 ml. I've got 5 ml in there now. And another half for a total of 5.5. Well, this is very strange. It's taken almost 18 minutes and a whole bunch more nitric acid than I figured to get this gold to go into solution. There was just a little bit there. It's just not dissolving. It's in a finely divided state. That stuff should have dissolved in about 2 minutes. So that's very puzzling to me. I cranked the heat on it. It's still got a few little pieces that just refuse to dissolve. I'm not going to chase after those. I'm going to pull this down off the heat and let this cool off. I got all the gold in solution. I don't know what those pieces are there. Might be some other metals, some platinum group metals that's following the gold. I'm going to pour this through a filter now. It's been allowed to cool down. This is it. This thing's had 5 chances to clear up. Hadn't cooperated, which is typical with platinum group metals. I'm done with it. This will be what I'll do is I'll precipitate this, melt it up into a butt so we can get a yield on it. But I'm going to throw it in with my next batch of carat scrap like I planned to do, like I should have done 2 refinings ago. And we'll be done with this. Add some SMB, precipitate out the pure gold. Should do it. Get this gold into a filter, get it melted, get it out of the way. This into a melt dish now, and we're going to get it over on the melt table, melt it up into a button, get a final yield on the gold from the stock pot. Rather than try to refine that stuff out of there with repeated wet chemical processes, what I'll do is I'll just throw this button in with my next batch of carat scrap and quart it with silver and then part it out with dilute nitric acid. That'll get the gold cleaned up real nice. Here's our pure gold button. Probably about 98% pure, something like that. 4.9 grams plus 7.9 is what? 12.2 12.8 grams total from the stock pot. 12.8 grams total. Now that I've got the gold out of the way, I'm going to turn my attention back to the platinum group metals here in my large container. It looks like I got a lot of metal in there. So I'll begin by siphoning off the liquid above the metal into a waste container there. This is all the platinum group metals that has been cemented out with zinc. It looks like a whole bunch, but looks can be deceiving. What I'm going to do now is add some tap water here. And what we're going to try to do is get the excess zinc burnt out of here. I'm going to add a little bit of hydrochloric acid. That's filled up to the 2-liter mark there. Now I'm adding about 200 ml of hydrochloric acid to make a 10-to-1 solution to try to burn out the rest of the zinc. Now I'll let this set until I don't see any more reaction inside. When that bubbling quits, that means that the dilute hydrochloric acid solution has dissolved the remaining pieces of zinc that are in with my PGM black powders. Piece of zinc right there. See how that 10% solution's dissolving that out of there? We'll get all the excess zinc dissolved out of here, and then we'll start rinsing it with hot water. It is the following morning. Here's our platinum group metals on the bottom of this 5-liter beaker. Looks like there's a whole bunch in there, but looks can be deceiving. What I'll do now is I'll siphon this solution off down into this waste bucket. You can actually see some platinum group metals settling on the bottom of the waste bucket. I'll get those out of there. Now that I've got all the excess zinc burned out of here with dilute hydrochloric acid, a 10-to-1 dilute hydrochloric acid solution, I'm going to siphon off this waste solution that's sitting on top of the platinum group metals down in here to my waste bucket. Step for myself, a little bit of the blacks went over into my waste bucket here. So what I'm going to do is I'm going to transfer our metal out of this large beaker, transfer it into this smaller beaker, then I'll pour the waste solution back into this beaker from that bucket, allow it to settle out, then I'll siphon off the liquid again, and then add the black metal that settles to the bottom into the main beaker. So I got all the metal in one spot. Here we go. Solution out of my waste bucket back into the beaker now. We'll let it settle out. It should settle out pretty quickly. And And then we'll get the rest of the black metal out of here and into the main beaker. There we go. Now I'll just let this beaker settle. It should come down pretty quickly. And then once this settles, siphon the liquid out of here, back into the waste bucket, and then we'll add the metal from here into the main beaker. This is a clip from earlier in the series where I used a little bit of zinc to cement out the black platinum group metals from a sample. I'll be adding this to the main beaker. This is some of the black mixed PGM metals that I cemented out earlier in the series with zinc. I'm going to add it to our main solution here. This was a sample that I drew off earlier in the series to see what kind of metal precipitation we were going to get. I'm just going to add it right in now. It's part of the stock pot refining material. This has been settling now for a couple hours. I'm going to siphon this off again, back down into my waste bucket. This has been settling a little while. I'm going to get this liquid here, put that in my waste bucket, and then I'm going to combine these two in this beaker here so I've got all the metal in one beaker. Now I'll transfer the black powder into our main beaker here. So we got everything all in one beaker. I've got some boiling hot tap water here. Our metals are about right there. That's the level. I'm going to add this boiling tap water. Try to rinse some of the dissolved zinc out of the metals. This is a highly concentrated solution, so the metal settled quickly. It's only been a couple minutes since I added that hot tap water. Now what I'm going to do is siphon this off and give it another rinse with some more hot tap water. Second rinse with hot tap water. Less than a minute to settle. And siphon this off into my waste bucket. Third rinse with boiling tap water. 7 boiling tap water rinses. I want to see what kind of pH we got going on in here in the beaker now. And it looks like about 5. I'm going to keep rinsing until I get it up around 7. These test strips are a little more accurate. So I'm going to do a test with one of these. And it looks like we're at, I'd have to call it 7. So we're good. We should be neutral. All the zinc should be rinsed out of here now. Now we'll get the water siphoned off of here. Beaker a little bit here. I reach in here with the pipette and draw off as much of the liquid as I can. This is our mixed black PGM powders, pretty clean here. What I'm going to do now is put it up on a stir plate and dissolve it with hydrochloric acid and hydrogen peroxide. Then we'll filter out anything that doesn't dissolve, concentrate the solution by evaporation, and then reprecipitate the platinum group metals with zinc one more time. Here, I'm going to go ahead and drop that into my black powders here. Turn the stir on, start stirring. I'm going to add some heat now. Here we go. Got some 12% hydrogen peroxide here. Bought it at Sally's Beauty Supply. I'm going to start adding doses of this. Let it react for a minute. I don't know how this is going to react. I've never done this much metal all at once. Temperature on it is 70.2 Celsius, 158 Fahrenheit. I'm going to put another couple doses of hydrogen peroxide in there. That didn't look good. I just added another dose of hydrogen peroxide and the beaker tried to spit it back out at me. So I'm going to have to take it easy here. If I don't watch what I'm doing, I'm liable to get a boil over. Alright, the temperature is 185, 84.8 Celsius. Add about 100 ml of hydrochloric acid. Doses of hydrogen peroxide. See if I can get something to happen here. It's not acting like I thought it would. next few shots, I just start pouring the hydrogen peroxide in, trying to get it to dissolve. Please remember that I'm kind of making this up as I go. This beaker's too small. I'm going to transfer this solution and the metal into this large 5-liter beaker. I'm concerned about getting a boil over with this small 2-liter beaker. Beaker up here on the stir bar and heater and continue with the experiment. I'm adding a couple of 100 ml of hydrochloric acid here, see if I can get the reaction going good. In this next sequence of shots, I just start adding dose after dose of hydrogen peroxide. I really don't have any way of telling whether or not the solid material has dissolved. I'm out of my experience level here dealing with this much material, and the color didn't quite look quite right to me there. It's looking green. I'm used to seeing an amber color or a burgundy color with the platinum group metals. So like I said before, I'm just kind of making this up as I go. This is it. I've used that entire bottle and about a quarter of another one, and I'm all out. That's almost a liter of hydrogen peroxide so far. Still, I don't think everything's gone into solution. It's about 75 more ml right here. Temperature wise here, we've got 186 Fahrenheit, 85.8 degrees Celsius. I'm going to reach in there and get me a Stannis test now. See what kind of metals we got going in the solution here. Got a nice orange stain there, so I got some platinum going into solution. While I was dissolving my PGMs over here, I noticed that the solution was turning green when I first started. So what I'm going to do is I'm going to draw a few drops of my solution up here. It even looks green in the dropper. I'm going to add a couple of drops of that to this middle beaker here, labeled stock pot. 1, 2 drops. I've got another solution back here. This is from some copper. This is a solution of copper. And I'm going to drop that into this beaker. 2 drops. 1, 2. I'm going to draw some of this ammonia here. This is 10% household ammonia. I'm going to draw some of it up into a pipette here. I've got tap water. Here I've got tap water with 2 drops of our stock pot solution. Here I've got tap water with 2 drops of copper in solution. Now I'm going to add the ammonia to each one of these, and you'll see a color change. see, notice here, I'm getting a bluish color coming into my stock pot solution, which tells me, compared to my normal tap water without anything in it, I've got copper in my stock pot solution. I'm going to add a little bit more ammonia to each of these, just to make it a little bit more vivid for you. This is my known copper solution. This is my stock pot. And this is just plain tap water. I'd like to talk a little bit more about these three samples. I started out with 3 beakers of tap water. To this one I added 2 drops of copper from my copper solution. To the center beaker I added 2 drops from our stock pot solution. And then to the beaker all the way on the left, nothing was added. That's just tap water. If you look back here at the stock pot sample, it turned blue when I added the ammonia, indicating that I have copper in solution in with my stock pot refining material. How did it get there? Well, if we look up at the reactivity series of metals, you'll see that I used copper to cement out traces of platinum group metals in my stock pot. Nothing above copper cemented out. All of that got discharged into my waste treatment bucket. It stayed in solution and went into my waste treatment bucket. But there's a little bit of copper in with the platinum group metals that cemented out as a black mud. When I dissolved everything, that copper went into solution with the platinum group metals. And then I used zinc to cement out the metals while the copper cemented out with the platinum group metals. And it looks like a black powder, indistinguishable from the platinum group metals. So that's how I got the copper in with my platinum group metals solution. After doing that test, I siphoned the solution that's been cooled and settled into the 2-liter beaker there. This solution will contain our platinum group metals. I just set it up out of the way here. This is the remainder of the black PGM powders that I still have to put into solution. Turn the stir bar back on, put some heat on it. Now I'm going to add about 500 ml of hydrochloric acid here. I've got a brand new bottle of hydrogen peroxide here, and I start adding it to the hot solution. I had to put the beaker directly on the hot plate to get it to heat up over 200 degrees. It's stirring in there, and I think over the course of these next 2 clips of video I added about 500 ml of the hydrogen peroxide. Here's a stannous chloride test. I've got a piece of filter paper in the end of a bamboo skewer there, so I don't have to reach my hand down in the beaker. I'll put some stannous chloride testing solution on it here. And as you can see, I get a nice orange stain, which indicates that I have platinum in solution. Now this is 4 times normal speed. At this point I'm fairly certain that I have everything in solution, but just to be sure I add another 150 ml of hydrogen peroxide to the hot boiling solution to make sure I've got everything in solution before I proceed. Take the 2-liter beaker in back, pour it through a number 2 filter paper to get any solids out of that solution. Next, I pour the contents of a large beaker through the same filter, and then I use a magnet to retrieve the stir bar. Next, I rinse the remainder of the contents from both beakers into the filter funnel. Here is a shot of the solids that filtered out of my solutions. What I'll do is rinse down the filter real good and then add it to my filter storage. Now I'll add the PGM solution to this large 5-liter beaker, clean beaker, and we'll get this ready to evaporate the solution down so that we can go to the next step, which is precipitate those metals out again with pure zinc. Now I set the solution on some medium-low heat here to slowly evaporate the solution and concentrate it so I can precipitate out the metals one more time with pure zinc. This will conclude part 6 of the stock pot refining video series. I got my final yield on the gold. This button here was 4.9 grams. The previous button was 7.9, so I got a total yield of gold out of my stock pot of 12.8 grams of gold. This will go in with my next batch of carat scrap, and I'll refine it and get it nice and clean during that refining. We've got all the metals put into solution. I'm evaporating the solution down to concentrate it, and then I'm going to cement all the platinum group metals out one more time with some zinc. I did some tests on my stock pot solution that I was dissolving. Found out that I've got some copper in there. That shouldn't be a problem. I should be able to get that out later on in the refining process. Please remember that you are watching me learn how to do this. I have absolutely no experience. This is the first time I've ever attempted to refine my stock pot. So you're watching me learn as I go. One more quick thing. I'm concerned that the yield on this is going to be low. It looked like I had a lot of metal in there when we first started. But judging by the Stannis tests that I got on the dissolved solutions, it doesn't look like there's very much platinum group metals dissolved into that solution. I guess we'll find out more when I get it concentrated. We precipitate it out one more time with zinc and go from there. This will conclude part 6 of the stock pot refining series. Thanks for watching.